Hello and welcome to Lab 5 Bounce by Benjamin Barre. The goals in this lab is to replicate a bouncing ball hit off of a golf club in GlowScript. I'll be using Newton's second law and the forces of gravity and drag to determine the trajectory of my ball. I started in Tracker where I found the X and Y data after hitting a ping pong ball um, and tracked its data as it bounced up and down, and then transported all the data into an Excel sheet where I then created a graph of the X and Y axes to show the real trajectory of the ball, which I will then be simulating and I'll compare it back to. The constants in this situation are the mass of the ball, which is 2.7 grams, the position, starting position, which was 10.4 centimeters in the x direction and 2.91 centimeters in the y direction, the velocity of the ball at the beginning, which is 1.26 meters per second in the x direction and 0.3787 meters per second upward in the y direction. We have a delta t of 0.033 seconds per every loop. The force of gravity is 9.8 meters per second. The j hat, so the direction of the force, is only in the y direction, as the force of gravity is the only thing that will be having effect here. And then the proportionality constant is 0.094. The main code that this consists of is the same from Lab 2, where I'm simply updating the FNet to be the force of gravity plus the uh, velocity of the ball in the y direction squared times the proportionality constant, which will make up for drag. However, I added a new part of the code which will replicate a bounce, where whenever the position of the ball reaches less than 0 in the y direction, I flip the position vector, and then I also flip the velocity vector, so that is now bouncing up. And then to replicate what it's like to have a loss of energy and the reason why the ball bounces slower and stops going as high, I subtract 1 from the velocity to give it that effect, and then repeat at the bottom. And here, I'll go ahead and show. So here is the actual trajectory, and then we will pull up the code in which you can see it stops and slowly bounces down. The velocity, as weird as it looks, shows how it decreases and then flips back consistently at a decreasing velocity each time. And if we go and look at the original trajectory, you can see it also bounces slowly down, besides the beginning where I hit it with the golf club. So what are the differences between these? Some key differences between the simulation and reality is the loss of height and energy when the ball has an impact with the ground, because it is not a completely inelastic impact. Without the small line that takes away some of the velocity, the simulation would continue to bounce at the same height for eternity. And one thing that is similar in both is that the x-axis is not being affected, and so therefore the ball will continue to move in the right direction without a change in the x velocity. Thank you.